All right, so here we go. The whole idea behind these next few videos is just word problems that deal in rational expressions and equations. So I am going to do one video per problem. So if you want, check out the videos. They'll be named like 1, 2, and 3, and that way you can check them out in order. The hardest problem for word problems is setting them up to begin with. So I'm going to talk extensively about the setup, and then you'll probably want to watch the solution and how I go about solving it a couple of times, because I'm going to go through it faster than normal. So here we go. Oh, come on now. All right, Jim's speedboat can travel blah, 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 blah. I blah my way through this because my first step on any word problem, any situation at all where math is being used, is to find out what it is I'm looking for. I notice that I need to find the speed of Jim's boat. All right, so step number 1, find the speed. Okay. I'm going to call that R. You can call it whatever you want. I do not prefer S because it looks like a 5 when you handwrite it. So if you would like S for speed, fine, that's good. I'm going to use R for rate, and this is going to be the speed of Jim's boat. It is, wow, BOAD, huh? All right, boat. We can try boat with a T. Maybe that'll work better. So now that we have that, we can go through and we can find out if there are any other things that we can kind of measure based on the speed of Jim's boat. So it looks like we have the speed of Jim's speedboat can travel 20 miles upstream against a 3 mile an hour current. In the same amount of time, it travels 22 miles downstream with a 3 mile an hour current speed. Okay, find the speed of Jim's boat. This is it. So we're good. Now, this statement right here is going to set up what version. We've got D is equal to RT, D over R is equal to T, and D over T is equal to R. Those are the other R, the kind of R that's not a 2. Those are the 3 different versions of the distance, rate, time problems. Those are the only 3 different formulas. So this here, in the same amount of time, this should not have been a separate sentence. It actually should have been connected, or at least a comma here. Anywho, in the same amount of time means that we're going to set time up equal to time down. That means that we need to know the time value. So we're going to use this distance over rate is equal to time. That's because we need to know the time value for each side of the equation. All right, so here we go. If I have these labeled as time up, so this is going to be the time upstream. So I look for the upstream. Speedboat can travel 20 miles, which is a distance, upstream against a 3 mile an hour current. All right, this is where we have to be extremely cautious, and we have to kind of look at this in a conceptual manner. To start off, I have 20 miles for my distance, and I'm going to divide that by his rate. So I want you to think about being in a river and paddling in a canoe, or if you've never done that, ride a bike against a wind, or go walk against the wind. Maybe even walk uphill. I mean, it kind of poses the same problem. So the point being is, if you were to, say, swim against a current, and then somebody was looking at you from the shore, they would notice that you're going slower because you have to fight the current. So even though you might swim just fine in a lake, it looks like you're struggling in a river when you're going against the current. That's because the current is fighting you. It's not helping you, it's fighting you. The current with a speedboat is still fighting him. The speedboat's just a lot more powerful. If you've never really thought about that or just don't swim, think about say walking or running into the wind. Do you think you run slower into the wind than you do with the wind at your back pushing you? And that's the kind of feeling that we're going for here. So the current is either going to help him, which means it's going to add, or it's going to hurt him, which means it's going to subtract. Now, the order of the subtraction is important because the speedboat traveling upstream against the current means that the current's going to fight him. So it's R minus 3. How fast his boat is going, and then the current is going to fight him 3 miles an hour. This represents the time. So this is the time upstream. That's what that entire term is doing. 20 over R minus 3 is all measuring the amount of time he's spending going upstream. That has to equal, because it says in the same amount of time, that has to equal the amount of time he spends going downstream. Well, he can go 22 miles downstream. How fast is he going, though? And this is, again, you turn around now, and instead of swimming against the current or walking against the wind, you are now swimming with the current. So you're swimming like you would in a lake, but now the current is also pushing you. Same way with the wind. If you turn around and run with the wind, you're actually going to run faster slightly. It's not going to be exactly this thing because it doesn't quite work that way, but you're going to feel like you're moving faster. And you will actually move faster against somebody that's just standing still. That's going to help you. So it's going to be however fast you run by yourself, and then it's going to add in. It's going to help you move faster. This is our time downstream when it's helping you. So our time upstream is equal to our time downstream because in the same amount of time it takes him to travel 22 miles. So this sets up our equation here. And now we're going to have to, how you want to do this is entirely up to you, but this is perfect for cross multiplying. It sets up a perfect proportion here. So I'm going to go ahead and cross multiply. That's going to give me 20 times R plus 3 is equal to 22 times R minus 3. And then from here, we just simply solve it out. So I'm going to distribute on both sides, get my R's on one side, get my numbers on the other, and solve. So I've got 20R plus 60 is equal to 22R minus 66. And then we'll go to blue. And I'm going to move my R's over to the right because it's going to leave them positive. So I'm going to subtract 20R from both sides. Then I'm going to add 66 to both sides to get both of my numbers on the left. 20R's eliminate, 66's eliminate, giving me 126 is equal to 2R. If I divide by 2, I get 63 is equal to R. So apparently his speedboat's moving. His speedboat runs on a lake. If he were to just open up the throttle and run, his speedboat's running at 63 miles an hour. That's pretty quick along the water. So, but it's not unheard of. So we can accept that as good. If we got a number something like 3 miles an hour, that doesn't make any sense because then he wouldn't go anywhere against the current. If we got something like 400 miles an hour, something that's way out there, it's like a boat doesn't go that fast. So we probably made a mistake somewhere. Again, take some time, set it up. That's the biggest problem with any word problem in math, is getting from the words to the math. After that, the math is easy. Usually. Sometimes. So, I hope this helped. Take care.